So in this particular lesson, what we're going to explore is the whole idea of tile and tile patterns. And it comes from the basis of creating some very simple designs through a rudimentary structure. So in this particular case, this structure is based on a series of related squares. So I'm going to be drawing a square here, 1 foot by 1 foot. And I'll start with that value, and I'm going to zoom in on the image so we can see it. And I'm going to duplicate that square above. So I'm just going to copy and paste it in place. I don't need to draw it again. And this sequence that we're going to go through is a very commonly known sequence to many designers. So the first square is 1 foot by 1 foot and it's doubled. And then we take the length of one of the two edges combined and we make the next square. In this case, it will be 2 feet by 2 feet. And we're going to do this in a clockwise direction. So we're going to move down below now and make another square 3 feet by 3 feet. That's the 2 foot plus the 1 foot. And we're going to create this particular square down below. And we'll continue the sequence around this shape. So the next one will be the 3 foot by 3 foot square plus the two 1 foot by 1 foot. So it will be 5 feet by 5 feet. And again, we're going to continue that clockwise direction. So I'm using the corners as my reference points. And above that will be the 5 plus the 1 plus the 2, which will give us our 8 foot distance horizontally. So we put that in vertically as well. We'll go 8 by 8. And continuing on in a clockwise direction, we're going to do one more, and this will be 13 by 13. Now, we're stopping here. This sequence can continue on forever, and this is known as the Fibonacci sequence, where the values in the squares are related to themselves. So you have a 1, 1, 2, 3, 5, 8, 13, and so on. You keep adding the previous number to the one before that. Now what we're going to do here is we're going to create a series of arcs to create a very unique spiral. And this is, again, a very well-known spiral. It's not something that's made up. It's something that's used quite common in creating this particular shape. And I'm just using the arc command, start, center, end. And because start, center, end requires that direction in a counterclockwise manner, we're going to start with the biggest one and go in a counterclockwise direction around this entire arc. And all I'm going to do here is press enter twice at the end of the command and I'll continue the arc. So this is a very particular spiral. It's also known as the divine section or the golden section. And it repeats itself quite commonly in all sorts of different areas, not only in art and architecture, but interesting enough, in nature. And since we're interested in landscaping, the shape of this and the repeating of the shape of this is very particular to landscape design. And not only is it particular to landscape design, but it's also particular to certain industries. And one of them is the creation of slate and slate tiles. And we'll get to that and we'll explore that a bit later on. But I just want to give you an idea of what this is and what we're drawing. So let's look at some ideas from the internet and what actually shows up. If you type in either divine design or if you put in golden section or divine section, you'll see that many plants and items in nature use that same rule, and that's a rule of growth patterns. So whether it be a shell or many different types of plants, they all use that same golden section to create the pattern. And there's a lot of different theories on why that happens. A lot of it has to do with gravity in some cases. That's one of the theories. And it relates to growth. It relates to, for instance, our skies and our, the heavens above and constellations. It also will relate to not only plants, but animals, but also in architecture and art. So Leonardo da Vinci, Michelangelo, all of those great artists use this method of proportion in their artwork because it's such a natural shape. And anytime we use this proportion, it feels very comfortable. It's a very human scale, no matter how big it is, because it's something that we can all relate to. And architecture is, common for using this, especially architecture from the Roman and Greek periods, several thousand years ago. So I'm going to type in here Fibonacci sequence or Fibonacci in architecture just to show you how all these Greek and Roman temples used that sequence, and some of the architecture today also duplicates that sequence. And even understanding and doing estimates and structure and support and all those kind of things uses this philosophy of drawing in order to create the effect. Even some landscapers have used that to create the landscape designs, and that's why they feel so natural walking through them, because they're using a natural scale of proportion. And that's really what we're talking about here is proportion, how things feel based on a scale from one to another. So you can spend the time on the internet and look at all these different options and how they come to place using the golden spiral, golden section, or Fibonacci sequence. And you can come up with all sorts of examples here online to see how it's been used over the centuries, over millennium, and what has been applied with that section. So I want to introduce this because it's something that we can also use in our own projects, and it's also used with masonry. And the Freemasons developed the technique of using this. So it's not something that's old, it's something that's really common. And in fact, when we're looking at tiles and doing patterns of tiles, random patterns, what we're doing is basically taking the simple shape, in this case 12 inch by 12 inch, and dividing it up into these multiples, whether it be 12 by 24 or 24 by 24, or so the 1 becomes a 12 and the 1 and 2 becomes a 12 by 24, and so on. So that applies to any size. So it doesn't have to be a 12 by 12, it could be an 8 by 8. So then it's 8, 16, 32, and so on. So these patterns are used quite often by tiles and pavers because they create this sequence. So I've gone to this Slate Products company that I use quite often to get the random patterns that they specialize in or recommend, because these random patterns not only give you the square footage of the random, but also the quantity takeoffs of each of the pieces. So it becomes very easy to do an accurate count and to order materials for a project. So if I decide on this random pattern, it will tell me how many square feet this particular pattern is, how much does it cover, and how many pieces of each size is required to create one of these modules. So if I know that, all I need to know is the square footage of my project, and then I know exactly how many of each size piece to be able to order for that particular project. So this information is really useful to us because we can apply it to our particular project. So let's take this information, let's take this graphic and see how it actually applies to our project. I've got this already set up where I've got the layers designed specifically to accept the image. And I have an insert layer and a pavers layer and all these different applications ready to go forward. So this is something that you would pre-do. And then you'd save that graphic image and you'd insert it just like we have before, insert it into our CAD file. So I have the insert layer current. Now this is a raster image, it's a JPEG. So as a raster image, unlike a PDF, it has a slightly different insertion methodology, but only in the selection of the first step. The rest of it is exactly the same, and you can see it here. And now I'm going to place it, and I'm sizing it. I have no idea what size it is. So let's say, for instance, in this example, I know that my first tile, which is the smallest one on this particular scale, is going to be of a particular size. So let's say, for instance, that particular size here, I'm going to pick, oh, I don't know, an 8 by 8. But before I do that, I'm going to go into my pavers layer, and I'll create a rectangle, and I'll make that rectangle 8 inches by 8. Or now, you know what? I'm going to make it 6 by 6. Okay, 6 inches by 6 is the smallest tile. Okay, so from here, I'm going to create a very accurate grid. And then that 6 by 6 will stand as the first number of my sequence. So the 1 in the Fibonacci sequence is a 6 by 6. So a 2 is a 12 by 12, and so on and so forth. But before I do that, I'm going to make a very accurate grid, and I'm going to use the construction line tool and select the four sides of the 6x6 grid. And now I'm going to determine what is my grout spacing. Well, in this particular application, the installation, the manufacturer suggests a 1/4 inch grout dimension for this. It's the way the tiles will lean up against each other. They'll allow you for a 1/4 inch grout line, so that's 0.25. And I'm going to offset this grid in both directions, horizontally and vertically, on all four sides of this square, 6 inch by 6 inch square, and then I'm going to duplicate this. So I've selected the two lines, and I'm going to then copy and paste it just like we had before, but I'm going to pick a base point that's at the opposite side of the 6x6, so then I can then just click on the different points and make sure that you're selecting the same point. Now I made a mistake here. I think somewhere during the lag time here it clicked in an inappropriate place, so I just undid. And now I'm going to continue to move forward and place my vertical elements here for my grid. And once I've got enough that I'm kind of happy with, I'm just guessing. I'm looking at it going, yeah, it seems to be okay. So now I'm going to take that, make horizontal elements, and I'm going to copy the whole section. And then I'm going to take that section and rotate it. And I'll pick a base point. And it snapped to a base point on that horizontal line. So when I rotate it, it's overlapping. And I don't like that because I'm not exactly sure if it's right on or right or not. And so I've just zoomed in on it and it looks like it's going to be slightly off. There it is. It's not exactly the way it should be. So I'm just going to undo, and that's okay. I'm going to undo, and this time I'm going to rotate it, but pick a location off the grid so it doesn't snap to anything uh, accidentally. There we go. And then I'm going to make sure it's rotated -90 degrees the way it should be, and then I'm going to move it into the grid position. So I select all those lines, and I'm not going to select the last one because that will be my base point, what I'm going to actually use as a base to copy from, and then move it up to where it's going to go, which is at the base of that one. Let's snap there. There we have it. So I've created a 6 inch by 6 inch grid with a 1/4 inch spacing in between. I'm getting rid of all these extra lines. I don't need them. Now I'm going to scale this background JPEG into my grid, and I'm going to trace over it with the accuracy of my CAD grid instead of depending on this graphic. Remember, this is a photograph, and it will have all sorts of distortion. So rather than risk the distortion and trace over top of it, I know that it's using the pattern, the Fibonacci sequence pattern. You can see here, it's such a poor graphic that when I zoom in, I can't tell which pixel's which. So it's just an estimate of shapes. That's all it's going to be used for. So I don't need that extreme accuracy, but I do want to be pretty close. So I'm going to select that grid, and you can see I have to really scale it back. So I'm going to use a technique we've already used before, which is select it, press enter, click on the base point, type in R and enter, and then stretch it. I'm going to first, well, shrink it. I'm going to shrink it to, or scale it down to the size of a single unit. So I'm just picking the width of a single one. There we go. I'm going to pick none so it doesn't snap to anything. And click and drag, and there we go. So it's not too bad, but it's slightly out. By the time I get to the extreme right, it's way out. So let me rescale it one more time. And again, because it's a photograph, it's of poor quality and the accuracy level's way off. So I want to rescale that. I click on my base point, type in R and enter, and then my base point again, and click on somewhere out here. I'm going to use none so it doesn't snap to any of the lines, and then click to and snap onto a line. You can see it's not bad. It's not accurate at all, but it gives me a sense of how big the tiles are. I can see very accurately that the first two in the upper left are 6x6. And as I move around, you can see it's slightly distorted at the bottom. That's okay. I may need a couple more grid lines at the bottom, but I'll work with that as time goes on and apply the grid lines as they're required. So what's the point of all this? Well, the point of all this is to be able to trace over everything here with a lot of accuracy. And that's really what's important. So I'm going to, in the paver layer, I'm going to make rectangles or these square shapes. But what I've done is used a temporary override. In the properties menu, I've selected the magenta color, even though I'm in the pavers layer. And you can see it's an override. And that allows me to then see all the different areas that I've actually drawn. And again, we have to use some liberal um, visuals here. The background image is not quite accurate to the grid, but I know the grid is accurate. So I'm going to use the grid measurements and snapping to those corners for each of these elements around here. So you can see a 6 by 6, and this would be a 12 by 12, and you get a 6 by 18. And I'm just zooming in and out just to make sure that I've selected the right grid points. And I'm going to work through this whole graphic image laying out this pattern. Now, it's important only because I want you to get the full picture of what we're actually doing so that you'll be able to repeat the process. So this is a 6 by 12. There's another 6 by 6 down here. And as I move there, oh, I'm missing some grid elements here. Let's take a look. Yeah, I'm missing a grid to the left there, so I'm going to put one in there. So I'm going to leave that for now, move on to this 6 by 12 and the 12 by 12, and continue working on. That's another 6 by 12. So remember, the accuracy of this is important because the number count's already done. The square footage is already done. So the estimator can easily determine this. Yeah, I just ran out of grid space. So I'm going to add those final horizontal and vertical grids as I need them, just to make sure that I can finish this off. So keeping that in mind, this is an excellent technique of drawing because it also will help with the pricing out of the project. And that's critical that we have an accurate price. It also will help us reduce waste, which again, today, we don't have money to waste, and neither does the project. And we want to make sure the project looks incredibly precise and that all the measurements were taken into account. And that's what we're doing here. Now, again, each manufacturer has a different dimension of tile, so we can't be switching between manufacturers. So one may be 6 1/4 or 6 1/8, another one may be 5 3/4 inch. So it's really tough to do a random pattern like this with multiple manufacturers, especially ones that have different grid sizes or grid spacing of individual components. So we really have to stick to one manufacturer. Now, we can have a second manufacturer doing, let's say, the borders on the outside, because they may not have a relationship to what we're doing here with the infill. So this is for the infill only. Okay, I've completed each of these tiles. And now I want to be able to actually take a look at this and see what my result is. So I'm going to go to the insert layer and take that off. See, I don't need to see that anymore. And these grid lines here, I don't need to see them anymore. Am I going to need them for anything else? No, and I can see how accurately I've drawn here. Oh yeah, I'm going to create an outer edge to this, and it will be the in-between space. I think it'll make more sense as we do this. So I'm going to use the polyline command and draw around all of these different elements. And it's still a bit confusing to see. I think it'd be better if I get rid of the grid. I don't need this grid anymore. So let's delete this grid, and I'm just going to follow that outer edge of shape with a polyline. Then I'm going to offset it to represent the grout. So let's go through this again. I'm going to go, and I have to use perpendicular. So some are endpoints, some are perpendicular points, depending on where they meet up. Because again, I've left a 1/4 inch gap, and there may not be intersections where I want them. And I'm tracing this with a single polyline. Now, why am I doing this? What we're eventually going to do is offset this polyline half the grout width. And then that becomes the unit measurement that we copy and paste this pattern to. And by copying and pasting this pattern to that grid, we have a very accurate square foot measurement of this particular pattern. And we can insert it in our project. Now, in some cases, we want to make sure that a corner is lined up with a corner. On curved driveways, it's not as critical because obviously the curves will cut into any of these square pieces. But if we've got a nice straight section, we want to make sure that we don't have what's called slivers. And so when we make the width of the driveway, we make it based on the modular distances of this particular grid line that I just drew, or I'm going to offset here by 0.25, because that allows for grout on the edge of each tile from one end to the other. So now that I've offset it, I can delete the original polyline because I don't want that anymore. So I'll click on it and delete it. These two are going to be treated a bit differently because I'm going to have paver 1, and then I'm going to have that line as my center for all the pavers. This is what I mean. I'm going to take this whole grouping of it and combine it into a single group. So if I select group, what this simply means is this: I can copy this in both directions right from that particular corner. And what I'm doing is actually overlapping the polyline corner. So it's where these two corners meet, these two here. and you can see the pattern. It's repeatable. It's tileable throughout the whole process. Okay, so I need that reference line in the process in order to group this and to basically cut and paste it in place, but I don't want that line. So I'm going to first ungroup this. So right click on it, group, ungroup. And I'm going to copy this. And the technique I'm using is to make sure I always have a single reference from the tile for the pasting operation. And I'm putting them in separate layers, and then I'm going to turn them off. So I have the paver 1 layer, and then I'm going to make a second paver 1, but this paver 1 will include that line, that reference line that I can then duplicate. So let me go in here, layer control. Let's scoot it all the way out here. Let's see if I can grab that and move that over. That's okay. So in here, I'm going to go into the paver 1 layer and then make a paver 1 reference layer. So that's that one, paver 1 reference. And I will make it a different color so it stands out. And that one I'm going to leave as magenta. Okay. Now originally I turned everything magenta because I wanted this to really stand out when I was tracing over top of it, because its original color was difficult to see. So I'm selecting the by layer process. So there's the right color. Okay. This I'm going to be putting onto that reference layer. Paver 1 reference. There we go. So there are 2 separate layers. Now this is what I'm going to be grouping, this series of elements here. So I click on it. I select group, group. So now it becomes a single entity for copying and pasting. But what I'm going to do is copy, and I'm going to leave this out here out in the middle of nowhere so that I can always go back to it. That is my reference grid. Why is this important? Because what we're going to be doing is this. I'm going to be showing a pattern, and then what I'm going to show beyond that is this. So it's very easy to see how that pattern is going to be laid out. So using this technique, I can show a builder how this pattern is going to come to place, how it's actually going to work within a driveway scenario. So let's try this. I'm going to copy this in its entirety. So I have both layers. I'm going to move to the drawing, and I'm going to pick a location and use it as part of my tile. So I may not want this tile that's in here right now. So let me just click that over here. I'm going to take that tile and see, you can see the group there. That's the way it was used for this one. And I'll turn that tile off. And this gives you an opportunity also, if you're working with a client, to have different examples. So do you like this tile pattern? This pattern? And you can turn layers on and off to display the different patterns. So there's my pattern. So I'm going to copy this and I'm going to move it in place. So the first one is going to go right into this edge here. Now you can see what's going to happen, and parts of it are going to get cut off. That's okay. So now I can paste this all over the project. So I'll start there and it goes to there. And see how I'm using the polyline to paste, and that will give me the gap between each of these. And you can see what happens on this corner. Now, you have a number of different options here. If you know the tiles you're going to use, you can actually change the width of the project to match the tile pattern. And that's a very logical thing to do, because then it works. And that's really what you can do in this particular example, so that as I tile it through the project, it fits perfectly in the project. And that's what you want to do, is not have cuts. A lot of times when I'm actually with the judging panel, we're looking for what we call slivers, where there are none. So if I have a sliver of a tile, let's say that very, very small section, we'll say right away that that project has slivers, which means that project isn't done very well. You've got to measure forwards and backwards. Even though this says 12 foot 5 inch center to center, and that's where you're going to band it, you don't work on that principle. You work on the principle of the tile that's coming in, along with the space that you're going to do, and make sure it fits perfectly. And here it doesn't fit perfectly. Look, this line coming through here interferes with that corner. So I would move that line over, and how far over? To that magenta colored line, so that I also have a grout position there for the sand or whatever you're going to fill it in with, and it fits perfectly. So these are all design considerations of the earliest of stages, so that when I actually go to draw my details, my tile details, I'm going to go to L3. There is the pattern. Notice how you want to make it fit along the edge and what the edge pattern is. This is all critical to the excellence of the installation. We don't want a haphazard, as it fits into space, cut the tile, but also think from the perspective of cutting the tiles, how efficient it is. Because if I'm cutting, and let me go back to the model, if I'm cutting out these tiles here, well, what I'm actually doing is cutting them right along their seams or right in the midpoint, so then I can continue on to the next tile or to the next placement of that tile and have a very efficient installation with minimum waste and great cuts. And that's what you'd like to be able to do within your project. So consider this when you're working on your particular project. And notice this, I've got two different layers. So when I go to print off the final um, paver detail and I turn off the references, there it is. It's perfectly fitted with the grout in all installations. And these we would trim off. I would ungroup that and then trim the edge. But I would have first moved over the ledge that we have on the ends to make sure it fits nice and perfect right in place with the rest of the tiling. And that's how you install, draw, and place your grid pattern. When you actually go to do the final L3 with the detail, you'd create that, you leave one layer on for the actual magenta color to show that outline, the pattern, and that's what this is showing me, is the pattern. So this corner where it says 3 and 1 fit in this corner right above here, and that's the repeat, and that's how you get the repeat for this. So understanding how this works, putting it together, drawing it up, and placing it on your diagram is all part of the process to be able to create an excellent plan for your project.